Okay, so let's solve a quiz related to cross product. Question 1 says we need to prove uh, a vector a plus b when dot product with a vector b plus c plus a gives you 2 times a dot b cross c. How do you solve this problem? So let's take LHS. We say a plus b dot, and we can multiply. You can solve the dot product by individually doing the cross product with the two entities. So we can say b cross c plus b cross a plus c cross c plus c cross a, right? So this entity is basically would go to 0. So we will have a plus b cross c plus b cross a plus c cross a. Now when a multiplied by this, we will give, and this is a dot product, we will give a dot b cross c. However, when a multiplied by this will give me 0, and a dot cross product with this will give 0, because these two quantities are perpendicular to a vector, and hence any dot product of these two quantities with a vector would be 0. Similarly, when I do b dot with this quantity and this quantity will goes to 0, because b cross c is perpendicular to b and b cross a is perpendicular to b, and so b dot anything which is perpendicular to b should be 0. So I will get b dot c cross a. Now we have seen that this quantity can be written as a dot b cross c by the property. So we can say this is 2 times a dot b cross c, which is equals to RHS. So hence we proved our first question. Let's go to second question. Okay, so question 2, we need to prove that if there is a tetrahedron, then its volume is given by 1/6 of a dot b cross c. So let's see a tetrahedron with the origin O, a vector, b vector, so OAB as base, and then c vector as its point. So what would be so first we need to find what is the area of this base. Now area of the base, we know from property of triangle, can be written as half base into height, which is half a cross b, a cross b, which is the determinant of a cross b, right? Now volume is nothing but 1/3 of the base into height. So we need to find height. How would you find height? So in order to find height, first we need to know what is the unit vector which is perpendicular to this base. So we know there's two vectors a and b in this plane. So anything which is perpendicular to this plane can be given by a cross b. And if we wanted to get to a unit vector perpendicular to plane, we just need to divide by its mod, which is mod of a cross b. So this is nothing but a unit vector which is perpendicular to this plane AOB. Now what is an height? So height would basically be projection of c vector on n vector, right? So that would be the height from c to this base AOB, which is c cos theta. If theta is an angle between the unit vector which is perpendicular to A or B and C vector, then the height is C cos theta, which can also be written as dot product of C vector and n vector. Now if we substitute n cap, we will get C dot A cross B mod of A cross B. Now let's substitute all of these values back to the formula volume. So 1/3 into area of base is half A cross B into, and I've used the asterisk sign so that we don't confuse between the dot product and the cross product and the multiplication sign, because these are all scalar quantities. These two are scalar quantities. And then we substitute the value here. And then we know that this and this will get cancelled out because these are both determinants, and we will get 1/6 of C dot A cross B, which is equivalent to 1/6 of A dot B cross C. And so we prove that the area of the volume of tetrahedron can be given by 1/6 of A vector dot B cross C vector, where A, B, C are the position vectors of its side. Great, let's move to next question. Okay. Third question, we wanted to prove that A cross B cross C is A dot C B vector minus A dot B in the direction of C vector. This is a very important property you should remain, because we will use this property to solve many other questions later on. However, how would you prove this property? Right? So let's consider two vectors B and C. Then any vector F which is B cross C is basically perpendicular to this plane. Let's say this is that plane. Right? So F vector would be in this direction, which is perpendicular to both B and C. Now if I say another vector, which is an F dash vector, which is A cross B cross C, which is equivalent to A cross F vector. Now if you look at this vector, so F vector is perpendicular to B and C. So if I'm doing a cross product of something which is perpendicular to the plane B and C, then this vector or this whole vector should lie in the same plane as B and C, right? So F vector is perpendicular to B and C already, because it's a cross product of B cross C. So anything which is a cross product of A cross F will lie again in the same plane as B and C. So we can simply say F dash vector is sometimes M times B vector plus N times C vector, right? Does that sound good? Now F vector is also perpendicular to A vector, right? So if I say A dot F vector, this has to be 0, which is equivalent to M A dot B plus N A dot C equals to 0, right? So because we need to find the value of M and N. So this implies M A dot B is equals to minus time N A dot C, right? So what does that mean? M be some constant A dot C, and therefore N would be same constant A dot B, but in the negative direction, right? So if I substitute these two values, I would get lambda equals to lambda in this equation. Do you agree? Now let's substitute M and N back to this equation. Let's substitute these values of m and n back to this equation. So when we substitute m and n value, we will get this equation. F vector, which is a cross b cross c, is equals to lambda times a dot c b vector minus lambda times, so we say a dot b cross c is equals to lambda times a dot c b vector minus lambda times a dot, sorry, not lambda will be out, c vector. Now this is a generic equation. So this is true for all values of vector a, b and c. So I can take any value that I want. So let's say a vector is equals to what should we choose? Let's choose I cap. Also choose c vector equals to I cap and b vector equals to k cap. So let's see this. So this is a, which is nothing but I cap cross I cross j. I cross j is nothing but k cap. Sorry, I cross k so this is nothing, so LHS is so I cross k is I cross j, which is again k cap. Right, so this is LHS. RHS is equals to lambda. This value is I dot I into k cap. I dot I is 1 minus I dot k, which is equals to 0. So this is value is 0. So this is equals to lambda k cap. So this implies lambda equals to 1. If I make these two equations equals, LHS and RHS implies lambda equals to 1. Now if I substitute back lambda equals to 1 here, I get this equation, which is a proof. Okay? Hence we can say a cross b cross c equals to a dot c b vector minus a dot b c vector. So this is very important equations. Let's remember these equations when we are doing vector, because we will be using these equations in most of our questions that we are going to solve. There could be one more crude way of solving this equation. I will show you. I will not explain you, but I will show you how to solve this from a crude perspective. So let us say what is a longer way of solving this same equation which we solved just before that. So we say that a vector in 3 dimension, a1 I hat plus a2 j hat plus a3 k hat, similarly b vector and c vector. We know that b cross c is basically determinant of this vector, where we say we put ijk, which is the unit vectors, b1, b2, b3, c1, 0, c3, and we solve this determinant. We get this equation, which is basically, if we say block this, then we say b2 c3 minus c2 b3 I hat with negative of b1 c3 minus c1 b3 plus, if I take this k, b1 c2 minus c1 b2 k. Now when I say a cross b cross c, it's basically, what does that mean? So it means a determinant between this vector and this vector. So this then becomes a determinant equation, and when we will solve this determinant equation, we will come to this equation. This is a longer way of solving the same equation. As I said before, let's remember this property, as this property is very helpful in solving many vector problems that we are going to see.